Section 7.6, normal form of a linear equation. We're going to start with one vocabulary term, and that is a normal line. If we're going to be writing something in normal form, we should probably know what a normal is. A normal line is a line that is perpendicular to another line, curve, or surface, and on the xy plane, the normal passes through the origin. So the normal is actually a thing. It's a line. Okay, normal form of a line. Let me show you what it looks like. Normal form says x times the cosine of, and now that's the Greek letter phi or phi. I'll write that off to the side here. I'll do it in purple. So this is, if you want to spell it, it's P-H-I. You can either call it phi or you can call it phi. I believe my high school math teacher called it phi. I know a lot of sororities and fraternities on college campuses have that letter, and that's usually phi. I really don't care which way you say it. It's just a circle with a vertical line through it. So we've had no solution before where we have a circle with a diagonal. This one has a vertical slash through it. Okay, so there is a difference between the two. So x cosine of phi or phi plus y sine of phi or phi and minus p is equal to 0. That is normal form of a line. And it would kind of help to know what some of these variables represent. Okay, so x and y really just mean x and y. But the other two, the phi, the angle, and then the p value, those are what kind of define the normal. Okay, so let me define these here. So phi is the angle formed. Wow, let's try that again. Formed by the normal and the positive x-axis, and then the p-value is equal to the length of that normal, the length of the normal. Oops, let's try writing that a little better. Normal. Okay, so let me kind of give you a visual of what we're looking at here. So I'm going to draw an xy plane, okay, x and y axis, and I'm going to draw a line through that plane. So really don't care what it is. It looks like that. The normal, I'm going to do it in red, goes through the origin, and it creates a perpendicular line, or it creates a perpendicular 90-degree angle with that line. So let me try drawing that a little better. Okay, your phi or your phi is this angle right here from the positive x-axis to the normal, and then your p-value is the length of that red line. Okay, so visually that's what we're looking at. We can define the original line we were given here. We can define this if we know this information using this equation. Okay, so let's try an example or two. Use the given information to write the normal form of the line with the given length and angle of the normal. Okay, so I don't have anything written here, so I got to write this in. Question number 1 or example number 1, our p-value is going to be 8, and our angle is going to be 45 degrees. Okay, so if we think about normal form of alignment, go back. I'm going to rewrite it on this page right here. So I'm going to say x cosine of phi plus y sine of phi minus p is equal to 0. Okay, but what we need to know is we need to know the p and we need to know the phi or the phi, whichever one you want to call it, don't care. We have those two pieces of information, so we can actually write our equation. We can say x times the cosine of my angle, which is 45, plus y sine of my angle, also 45, minus my p-value, which is 8, and that's equal to 0. Okay, let's try to simplify this a little bit. Cosine of 45, we do know what the cosine of 45 is, not x equals. It's going to be x times cosine of 45 is square root of 2 over 2. Sine of 45, same thing as cosine, actually, so that's going to be also square root of 2 over 2, and minus 8 equals 0. Now, if you want, what you can do is you can multiply both or all parts of this equation by 2, because what that will do is that will eliminate these two fractions. And if we're going to multiply these by 2, we have to multiply this by 2 as well. So if you want to jot off to the side, we're going to multiply all parts by 2, just so we can eliminate the fraction. Go ahead. What you're going to be left with is the square root of 2x plus square root of 2y minus 16 equals 0. And this right here is the equation of your line. Let's try another one here. Number 2. Our p-value is equal to 12, and our phi is equal to pi over 6. Okay, so we're in radians this time, but that doesn't really change anything. Our formula is still the same. It's still going to be x cosine of phi plus y sine of phi minus p equals 0. So let's plug everything that we know in. We're going to say x times the cosine of pi over 6 plus y times the sine of pi over 6 minus our p-value, which is 12, and that's equal to 0. Let's fill in what we know. We know the cosine of pi over 6. That comes from the unit circle. So x times cosine of pi over 6 is going to be square root of 3 over 2. Square root of 3 over 2 plus y times the sine of pi over 6 is 1/2. And then minus 12 equals 0. Once again, since both of these are over 2, I think it makes sense to multiply all of this by 2 just so we can get rid of those fractions on our variables. So we can say square root of 3x plus, let's see, that's just 1y, so y minus 24 is equal to 0. And that would be the equation of our line with the given information. In the assignment for section 7.6, you're going to be asked to convert the equation of a line from standard form into normal form. Okay, standard form is just ax plus by plus c equals 0. It's very similar to normal form, but the a is not equal to the cosine of phi, and b is not equal to the sine of phi. So we're going to have to do some changes here. So to convert from standard form to normal form, what you're going to do is you're going to divide all three terms by plus or minus the square root of a squared plus b squared. And the question then becomes, well, how do you know which one to divide by? You're not going to divide by both. What you're going to divide by is the sign that's opposite this c. So we'll say sine is opposite c. So for this part, the sign is going to be opposite c. So when I've got an example down here, writing each equation in normal form, what we need to do first is we need to figure out what we're going to divide both terms by. So what we need to figure out first is whether or not we're going to use plus or minus, and since this is negative, we're going to go opposite of that, so we're going to use the positive square root. So we need to go positive square root of a squared, so a is 2, so we're going to have to square that, plus b, which is 1, so b squared. Whoops, I should have made that 1 squared, not b squared, 1 squared. 2 squared is 4, 1 squared is 1, so that gives me the square root of 5. So we're going to divide both of the, or not both of these, all three of these terms by the square root of 5. Okay, so let's do that. So let's have 2x divided by the square root of 5 plus y, or 1y over the square root of 5 minus 5 over the square root of 5, and that's equal to 0. 0 divided by the square root of 5 is still 0. Now, we really would not like these square roots to be on the bottom, so we need to multiply each term by the square root of 5 over the square root of 5, and what's going to leave us with is we will have 2 square root of 5 over 5, and usually in the textbook you'll see the x written off to the side of the fraction. Same thing with the y values. We'll have square root of 5 over 5y, and the top becomes 5 square root of 5 over 5, which actually those will cancel out. So really, if you want to write another line, you can. Otherwise, you can just erase that, and this is going to become just the square root of 5, and this is still equal to 0. This is your normal form when this is standard form. Okay, there's a slight difference between the two. Let's try another one here. Number 2, 3x minus 7y plus 9 equals 0. We need to figure out what we're going to divide all three terms by, and remember that's plus or minus square root of a squared plus b squared. And remember, the sign here is the opposite of this one. So this time our c value is positive, so our square root is going to be negative. So I'm just going to erase that plus or minus, and I'm just going to go negative. Okay, make that negative. So this is going to be negative square root. A in this time is 3, so negative square root of 3 squared plus b, which is negative 7. We're going to square that as well. 3 squared is 9. Negative 7 squared is 49. 9 plus 49 is 58. So we're going to divide all three terms in our original equation by the negative square root of 58. Okay, so let's actually go ahead and do that. Let's say we'll go 3 over the negative square root of 58, and then we'll have an x off to the side, minus 7 over the negative square root of 58y plus 9 over the negative square root of 58 equals 0. Okay, we really would like these to not have square roots in the bottom, so we're going to have to simplify all three of these fractions. So let's go ahead and do that now. We're going to need to multiply all three sides by square root of 58 over square root of 58. So positive divided by negative is a negative 3 square root of 58 over 58x. For our middle term, negative divided by negative is a positive, so this is going to be plus 7 square root of 58 over 58y. And then lastly, our c term, our constant term, positive divided by negative is a negative, and then we'll have 9 square root of 58 over 58. I don't believe 9 and 58 can be simplified. Same thing with 7 and 58 or 3 and 58. So we are simplified as we can get, and that's equal to 0. So this right here is our final solution. Last couple of examples here. Find the length of the normal and the angle it makes with the positive x-axis of the previous two examples. So we're going to be back to the orange one and the purple one here. We actually need to find the p-value, and then we need to find our phi, or our phi angle. Okay, so let's jump right into number one. So number one, my final answer was in orange, so I'll work in orange here. I'm going to rewrite the equation. Actually, I'm not going to. That doesn't really need to, because we can just scroll back and forth. So our p-value, if we remember what normal form looks like, okay, right here or right here, and p is the length of the normal. So this number, if we're in normal form, the number on the end that doesn't have an x or y, that is the length of our normal. So if we go back to our original problem, this number right here without an x or a y, that is the length of our normal, not the negative part, just the number here. Okay, so for number one, when we're finding the length of the normal, that's p, that is equal to the square root of 5. Now the angle, you have some options here. Okay, so we can say, thinking back to normal form, that the cosine of phi is equal to, well, that's the number in front of x, so we could say 2 square root of 5 over 5. 2 square root of 5 over 5. And the sine of phi, that's the number in front of y. Let's go back again. That's square root of 5 over 5. Square root of 5 over 5. What we need to do is we need to find the angle. And so I'm just going to, off to the side here, I'm going to write this in green. You can do either one of these, okay? The reason we can do either one, so the cosine is positive, the sine is positive, so our angle here is going to be a quadrant 1 angle. Okay, so it's not going to matter, because thinking back to principal values, quadrant 1 is always a principal value for sine or cosine. So it doesn't really matter. You can use inverse operations. Let me go back to the pen. Inverse operations, or the inverse function for sine or cosine, doesn't matter. Either way, if you use cosine inverse or sine inverse, you're going to get the same answer. Phi is going to be approximately 26.6 degrees. So you would do that by either saying phi is equal to the cosine inverse of 2 square root of 5 over 5, or phi is equal to the sine inverse of square root of 5 over 5. And either way, you're going to get the same angle. So it says we need to find the length of the normal, that's your p-value, and then find your angle it makes with the positive x-axis, that's phi, and we've done that. So we are good to go with number one. With number two, our p-value, again, it's that number without the x or y on it. And again, it doesn't matter whether this is positive or negative, so we can just say that our p-value, because we're looking for a length, my p-value is equal to, what do I have there? 9 square root of 58 over 58. So 9 square root of 58 over 58. Now, when it comes time to find the angle, we are going to have to do a little bit of thinking here. We can still keep the same idea, where the cosine of phi is equal to, we can look back at our equation. Cosine of phi is equal to negative 3 square root of 58 over 58. And we can say the sine of phi is equal to, if we go back again, 7 square root of 58 over 58. Now, if we do a cosine inverse or sine inverse, our angles are actually going to be different. Okay, so if I said phi is equal to the cosine inverse of negative 3 square root of 58 over 58, that would tell me that phi is approximately 113.2 degrees. If I do the sine, so my phi is equal to the sine inverse of 7 square root of 58 over 58. What that's going to tell me is that my angle is approximately 66.8 degrees. Now the question becomes, which one is the correct answer? Well, cosine is negative, sine is positive. The only quadrant where the cosine is negative and the sine is positive is quadrant 2. And of these two angles, only one of them is in quadrant 2, and that would be 113.2 degrees. We would have to think about going 66.8 degrees into quadrant 2 from the closest x-axis to get to 113.2. So this is technically kind of correct. This would be the reference angle for 113.2 is 66.8 degrees. But if we're looking for the angle that the normal makes from the positive x-axis, then it's got to be the actual quadrant that it's in. If we say 66.8 degrees into quadrant 2, you know, technically that's not incorrect, but 113.2 sounds much better. So sometimes it's not going to be just, oh, pick one and go for it, because sometimes, yeah, it's going to work. You're going to get the same answer either way. But sometimes you're going to have to actually think, okay, my cosine is negative, my sine is positive. What quadrant would give me an angle that would have a negative cosine and a positive sine? And that's going to be quadrant 2. So sometimes you could still get 66.8 degrees, but you have to understand that's not in quadrant 2. You have to go 66.8 degrees into quadrant 2, and that's where you're going to come up with 113.2.